Let's move on now to talk about combinations and see how they're different than permutations. The key difference is permutations are arrangements, combinations are just groupings. So essentially a permutation order matters, in a combination order does not matter. But let's look at an example. It says consider 5 members of a club volunteer to represent the club at a competition. Maybe it's our math competitions. Only 2 students can go. The names of the students that will get to go will be drawn from a hat at random. How many different pairs of students can be drawn to attend the competition? So if we think about this, we've got 5 people who are trying to go, and we're only going to pick 2 of them. And what we want to do is figure out how many different pairs are there that can go. But if we think about this, if one person gets picked first, they still get to go to the competition. Even if they had gotten picked second, that wouldn't have changed their ability to go to the competition. So it doesn't really matter whether you get picked first or second. It doesn't matter who's first or second. They both are going to go to the competition the same. So let's just name our students A, B, C, and D to simplify things, or an E. Okay, and so the idea is I could pick A, right? If we wanted to list out the sample space, I could pick A and B, right? Or I could pick A and C, or I could pick A and D, or I could pick A and E, right? But once I move on here, if I start with, now I'm going to start with person B. Well, I'm not going to put B and A because they're already listed as a pair, right? In this case, the order doesn't matter that they get picked in, so I wouldn't bother putting B and A because that's a repeating pair. So I would just move on to B and C, and then B and D, and then B and E. And as I keep going, I'm going to see that I can eliminate all these repeating pairs. If I pick C first, well, I won't pick C and A. I also won't pick C and B, so I'd move on to C and D, and then C and E. And then lastly, if I start with D, well, I'm not going to put AD or DA. I've already got that pair. I'm not going to put DB. I've already got that pair. And I'm not going to put DC. So I'm only going to add DE. And if I think about, if I pick E first, well, E has already been paired with everybody else in this set, so I don't need to put any more pairs that start with E. So since order does not matter, there will be 10 possible pairs. Okay. It doesn't matter the order that they get picked in, or the order that they get on the bus, or the order that they enter the competition. They're going to go and compete together. So order does not matter. This is a situation where we talk about combinations. So a combination is an element of a set in which order is not important. Okay, that's the key here. Order does not matter for combinations. And so, if we want to talk about the computations for combinations, here is the formula for it, right? It's similar to the permutation formula, but if we do NCR, we're actually going to take the total possible permutations, and then we're going to divide out RPR. If you think about this, R is the subset that's being selected. What you're doing here is dividing out the ways that you can arrange the subset. Think about this example. If we had 20 people, we know there's 20 different ways to pick, 20 different orders to pick those people. But then we need to divide out the repeats, because if there's a pair, there's 2 different ways to arrange a pair. We divide out the repeats. Total possible arrangements divided by repetitive arrangements equals the ones that we're interested in when order doesn't matter. So we take out NPR, the total possible arrangements of the subset, and then, or of this number from this large of a group, and then we divide out RPR, which is the possible ways of arranging that subset. In other words, NPR over R factorial. Again, you're going to use a calculator, so you're not going to need to memorize that or work through it really by hand, but that's sort of the logic behind it. So NCR has this formula. You'll see sometimes NCR can be written in this stacked notation where we just put the 2 values in parentheses on top of each other. It's the exact same thing. It's just a different notation. This notation gets used a lot in probability and stats. Maybe just to save space. It looks kind of like a fraction. It's not a fraction, no fractional bar in the parentheses, but these are 2 different ways of saying the same thing, so that's all this blank is here. And we can read this as NCR, or you'll often hear it as N choose R. So if you have n objects and you're going to choose any r of them in any order, n choose r, different than npr, okay? Again, to show the computation from our example above, if we had 5 C2, that would be equal to 5 P2 divided by 2 P2. In other words, 5 P2 over 2 factorial. 5 P2 is really 5 times 4 divided by 2, which is 10. Okay. So that's the setup for combinations. Here we can look at how to do them in the calculator real quick. If I wanted to do, here's the directions for the Inspire calculator. Again, we just go to the menu, go to probability, choice 5, and then it's right there, combinations. And again, we list it as a pair, sort of basically as an ordered pair. We have 5 objects. We're choosing 2 of them. There we go. We get the 10 that we saw. Okay. In the scientific calculator that I've been working with here, we would do 5. Then the probability button in choice 2 is NCR. So 5 choose 2, and there's our 10 that we saw. Okay. So that is the difference. That's how combinations are different, and that's how also how we compute them. And again, you'll be wanting to use the calculator. Make sure you know how to use your calculator to compute combinations.